We can also show the inputs and outputs in a table, which you've been doing for probably a long time at this point. The table looks almost exactly like the mapping. It's in a different form. Here's the input, here's the output. And if I pick 4, I'm still following the same rule, add 5 to the number I pick. So if I pick 4, you would say 9, -2, 3, 0, 0 plus 5 is 5, -5, -5 plus 5 is 0, and 3 plus 5 is 8. So I can put it in a table. And again, I'm thinking about this as I stand up here. In no particular order. I just sort of, I'm thinking of 1029, I think. Okay. All right, that little pentagon. What were the 5 things on there? A graph? Okay, so we still need to do a graph of this problem. A table. We got that one. Concrete or pictorial representation. A verbal description, and her formula, an algebraic expression, so those go together. Some equation, I'll put equation, but some equation which might be a formula. You know what, in a few days, in a few class periods from now, I'm going to talk about the difference between a formula versus a regular equation. I'll tell you right now, but let's get the last one up here. Verbal description. So for this problem, the verbal description is what I wrote when I said here's a rule. Add 5 to the number. The mapping is the concrete or pictorial representation. The input-output table, there's the table. The equation, what would the equation be? Let's say the input is X, which we did in the mapping. What's the output? X plus 5. So what you did when you took algebra was you wrote things like this. Y equals X plus 5. So there's an equation. Now, technically this is not a formula. A formula would be something that I could use for all sorts of problems, like a category of problems. Like, we'll look at this later. What is the formula for the area of a rectangle? It is area equals length times width. That works for every rectangle. So that would be classified as a formula. This is just for this problem. And maybe some stories we could make up that would fit this problem. So this is not something that if I'm trying to solve a bunch of categories of problems that I would pull this and say, oh, here's the formula I need to use. So basically this is just an equation. I got the equation, and let's see, I will do the graph. So this is the kind of graphs you did in algebra. And anybody remember what that graph might look like? It is a line. Now, what's the y-intercept? at 0, 5. The slope is 1. Are you going to be doing this with your elementary school kids? Probably not. Let's see. I went up 1 over 1. You probably will be talking about functions. Are you going to be showing them how to graph parabolas and logs? And probably not. But, you might show them. You might have a reason to do some sort of little elementary type graph. I'm thinking of something I've seen. I'm going to have to see if I can track it down and bring it in. Some solutions that some kids had given to some problems. I heard it in a talk. I'm going to see if I can find it. But not right now, for another class period.